Chapter number 7, Permutations and Combinations. This is totally new concept for 11th standard students. And it's very important also. We'll use frequently these concepts in 11th and 12th standard. Let's see. Interesting also, you will realize. Permutation means precisely arrangement, remember. Permutations means arrangements. You will see arrangements of objects. We'll have that concept here. And combination means selections. There the order is not important. So over here, the meaning of combinations means you are going to select something. So here selections, where the order is not important. How you select the objects, that's not important. Combinations means selections, and permutation means, as I told you, arrangements. You will see. Permutations means arrangements, combinations means selection. Okay, you will realize later on as we move further. But before we get into permutation here, two things I want to discuss. One that's called counting principle or principle of counting. Principle of counting or counting principle. So first one is this. Principle of counting, or you can call it counting principle. Now what is counting principle? See, if I take this simple example, you will realize, suppose I have one place A here, I have another place B here, and one more place C here. Suppose there are two ways from A to B and three ways from B to C. Way number 1, way number 2, and way number 3. Three ways from A to B. Two ways from A to B, three ways from B to C. My question is how many ways? My question is how many ways or paths? How many ways are there from A to C? That's my question. A to C, obviously via B. That is the question. How many ways are there from A to C via B? That's the question here. What do you think? Your answer may be just 2, or your answer may be just 3, or your answer may be just 2 plus 3, 5. Right? What do you think? Or your answer may be 2 into 3, which is 6. There are several answers you may be having in your mind, right? Let's count. You see, I'm just counting. 1, 2, 3. Now you must have realized what I did. 4, 5, and 6. So 6 is the correct answer. So what's that 6? That's a product of these two. That's called the counting principle. If one thing can occur in 2 ways, another thing can happen in 3 ways, then the total number of ways of occurring both means here, you will notice later on also, both means here and, remember, and means you will see product. And word precisely refers to product. So 2 into 3, which is 6, right? If I add one more here, for example, there is one more place. Now question becomes complicated, remember, and it's not easy. Suppose there is one more place, C to D, and there are, for example, 2 ways. Now if I ask you, earlier it was very easy to count also. Now if I ask you how many ways are there from A to D via B and C? So that by counting principle, 2 into 3 into 2, that is 6 into 2. So there are 12 paths, remember, from A to D via B and C. So that's counting principle. Why 12? 2 into 3 into 2. So it would be 12, remember. Right? So one thing can occur in 2 ways. Second thing can occur in 3 ways. Third thing can occur in 2 ways. the total number of ways of occurring all the things together, that is their product. This is known as counting principle. Okay, so I'm just stating. So now in this chapter, when you find this occurring like this occurring like this occurring like this, so you are speaking one by one, and when you have and, you write into means product. So counting principle says that if one event means anything, one event can occur in, let's say, small m ways. One event can occur in m ways, and second event which follows by this event, and another event can occur in, let's write, n ways, small n ways, then total ways of occurrence of these events is their product, m into n. Right? The statement is not important, remember. Important one is concept, right? As I explained here in a diagram. So total number of ways of occurring both the things, that is m into n. If I have 3 events, for example, third event can occur in k ways, then m into n into k. That's what the counting principle. When you have number of occurrences, and if you are asked they are occurring, find the number of ways of occurring all the events together, that's given by their product. As I explained here, your answer is 6. If there are 2 events, here are 3 events, so answer is 12. That's counting principle we'll use effectively in this chapter. You will see the number of ways of occurring all events, that's given by their product, m into n. If you have one more event which can occur in k ways, then the m into n into k, that way. I've just written here for 2 events, remember. Okay. Now the next concept which you have not studied earlier, I suppose, that's called factorial symbol. So let me write that here. The next point is definition of factorial. So how do we define the factorial? It is defined for any positive integer. So for any positive integer n factorial, this is read as n factorial. How do we read? N factorial equals to, it is given by the product of the first n numbers. That is n into 1 less n minus 1, then 1 less n minus 2, and so on till it is 2 and the finally 1. This is the definition of factorial. Product of the first n natural numbers is defined as n factorial. For example, what is 3 factorial? That is 3 into 2 into 1, only positive integers, which is 6. 3 factorial is 6. What is 4 factorial? 4 into 3 into 2 into 1. So this is 6 into 4, 24. What is 5 factorial? That is 5 into 4 into 3 into 2 into 1. Product of all this, 120. What is 6 factorial? That is 6 into 5 into 4 into 3 into 2 into 1. Right, 5. So 6 factorial is nothing but this is 120 into 6, which is 720. Right, 7 factorial and so on. Okay. Before that, let me write 2 factorial. 2 factorial is just 2 into 1, that is 2. What is 1 factorial? That is just 1. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720. At least up to this you need to remember. 7 factorial, 8 factorial and so on you can write. You can write what is next 7 factorial, right? That is 7 into 6 into and so on up to 1. Now this much is 6 factorial. 6 factorial you know it's a 720. So the 720 into 720 into 7. So it will be 5040 and so on. You can do it further. 7 factorial will be 5040. Further you can write. But at least till 6 factorial it should be there in your mind. 1 factorial 1, 2 factorial 2, 3 factorial 6, 4 factorial 24, 5 factorial 120, 6 factorial 720 and so on. Now one more here. We write definition. Here 0 factorial is not important, not defined, I'm sorry, but here definition of 0 factorial is 1. It can be proved also, remember. I'll prove it if I get the chance. But we define here. This can be taken as a definition, remember. It can be proved also, as I told you. 0 factorial is 1. 0 factorial is equals to 0, not correct. 0 factorial is 1, remember. Okay. Fine. Now here especially, you might have noticed, if I have, for example, 5 factorial, you know it is 5 into 4 into 3 into 2 into 1. Now what is this? This much is nothing but how much? 4 factorial. So 5 factorial you can write 5 into 4 factorial. That means every big factorial you can express into a smaller factorial. Because every time to get the factorial value is not easy task. Every bigger factorial can be expressed into a smaller factorial. You can do like this also. If I take only last 3 terms, so this I can rewrite as 5 factorial equals to 5 as it is, 4 as it is, and what is this? 1, 2, 3. It's nothing but 3 factorial. Smaller factorial. Every bigger factorial you can express into smaller factorial. For example, you see here, suppose I want to have 9 factorial. So 9 factorial, you know, you can have 9 into 8 into 7 into 6 up to 1. Now I'll drop only 9. What is this? 1 to 8. So 9 factorial is nothing but the 9 into what is this? 8 factorial. So 9 factorial I've expressed in terms of 8 factorial. So here is a result that says that n factorial can be expressed in form of n minus 1. This is always true. As a simple result you can write here what this result says. If you have n factorial, that you can write as n into n minus 1 factorial. Right? Smaller factorial, this is bigger factorial. You know this is n into n minus 1 up to 1, and that is nothing but the n minus 1 factorial. One more, I already explained. One more time. Suppose I have, let's write 15 factorial. This is very big number, so I can write 15 into 14 and so on till 1. Now this much you know, 1 to 14, that's 14 factorial. So 15 into 14 factorial. What is important one here? Every bigger factorial you can express into smaller factorial. Suppose you are asked to evaluate this, for example. Evaluate this is a question. Let's write 6 factorial upon 4 factorial. Now one way is here comparatively factors are small, you can write the values. The another way is you can write like this: 6 into 5, then you have 4, 3, 2, 1, which is 4 factorial upon 4 factorial. So this will get cancelled. So this is 6 5s are just 30. So 30 is your answer. So when you have a ratio of factorial symbols, you can express like this, remember. Suppose I have, let's write 20 factorial upon, let me write 17 factorial. Now this is very big number, 20 factorial, but I know this is a smaller factorial. So 20 I can express in form of 17. How? 20 into 19 into 18. Now you got this number, so stop this and write the factorial upon 17 factorial. This will get cancelled. You must have realized how I wrote. What is 20 factorial? 20 into 19 into 18 into 17 up to 1. And that gives us 17 factorial. That will get cancelled. So your final answer is 20 into 19 into 18. This is the value of the factorial. So we'll use this effectively, remember. Okay. So that's factorial concept. I hope you are clear with this. This is useful only when you have remembered ratio of factorials. Suppose I'll take one more example here. Find x. This is the question. Find x. You are given 1 upon 8 factorial plus 1 upon 9 factorial equals to x upon 10 factorial. Now the one way is you can put one by one values of 8 factorial, 9 factorial and so on. But it becomes difficult, you know. So what we do, we start with this, we write each one into a smaller factorial. So here 1 upon 8 factorial as it is. Here what is this? 9 into smaller one, that's 8 factorial. 9 into 8, it's like this. Again I'm emphasizing 8 into 7 into 6 till 1. And what is this? This is 8 factorial. X upon 10 into 10 into 9 into, I'm getting now 8. So I'll stop and write the factorial. Whenever you stop, put the factorial. Now you see everywhere you have 8 factorial. So you take this much common and you cancel from both the sides. So what we get here, 1 plus 1 upon 9 equals to x by 90. And this you can simplify very easily because this is nothing but just 10 by 9. 90 will go that side equals to x. So here just x would be here. What is x? X would be 100. Right? So this way you can simplify, remember. What I'm trying to explain you here is bigger factorial should be written in form of smaller factorial. Okay, fine. Now I'll go to exercise 7.2, which is very simple exercise based on factorial symbol only. 7.1 we'll do later on. We are going for 7.2 first. The first question is here, evaluate. First one, 8 factorial. So you know what is that? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You know answer to this. At least till 8, 9 factorial you should remember. It is 40,020. You can just verify. Okay. Next. Next one is 4 factorial minus 3 factorial. There's no way to do such subtraction question. The only way is do directly. 4 factorial, you know 24. 3 factorial, you know it is just 6. So you will get 18 here. Okay. Question number 2 here. Is this true? 3 factorial plus 4 factorial equals to 7 factorial. That's the question. So obviously answer is no. Remember, we don't have such property. You can verify. What's a 3 factorial? 6. What is 4 factorial? 24. So here this is just 30. And what is RHS? 7 factorial. You know it's very comparatively big number, 5040. So these two are not equal. So obviously this is not true. Third question, compute this expression. Compute here 8 factorial upon 6 factorial into 2 factorial. So how will do this? as I told you in the solution, write the 8 factorial in terms of 6 factorial. No need to put the individual values here. So 8 into 7, now you have 6. So you stop and write the factorial upon 6 factorial into 2 factorial is 2. This will get cancelled. 8 7 the 56 by 2. So we'll get the 28. Right? Okay. Next one. At this place, which as I shown there. Question number 4 here. 1 upon 6 factorial plus 1 upon 7 factorial equals to x by 8 factorial. So what we do? We reduce each of these into smaller factorial. By 6 factorial as it is. 7 you can write 7 into 6 factorial. 7 into 6, you stop and write the factorial. What about 8 factorial? 8 into 7 into 6 factorial. Now what happens? 6 factorial will goes away from this expression. 6 factorial, 6 factorial and 6 factorial. This will get cancelled. So 1 plus 1 upon 7 equals to x by 56. So this is 8 by 7 into 56 equals to x. So you will get x equals to here 64. Question number 5 here. Evaluate n factorial upon n minus half factorial. The first sub question is n is 6 and r is 2. R is 2. So here 6 factorial upon 6 minus 2, which is 4 factorial. So bigger into smaller. 6 into 5 into 4 factorial upon 4 factorial. This will get cancelled. 6 5s are 30. Okay, next one here. N is 9 and r is 5 here. So n factorial upon n minus r factorial equals to 9 factorial upon 9 minus 5, 4 factorial. So we write 9 factorial in terms of 4 factorial. So 9 into 8 into 7 into 6 into 5. Now you have 4. So we stop and we write the 4 factorial upon 4 factorial. So this will get cancelled. And if you just here simplify this product 98765, it would be just 15,120. Just simplify, you will realize.